Um, Welcome everybody to our webinar today. We are very excited to have Laura Pilossoph from Duke with us today. Laura will be presenting her work on labor market search with imperfect information and learning. And many thanks to our amazing panelists to be taking the time to be with us today. We're going to follow our usual format. So the seminar will be 1 hour followed by a 15-minute Q&A. So with that, Laura, please go ahead.
Great. So thanks so much for having me here, and thanks to everyone in the audience and especially the panelists for joining. So this is joint work with John Conlin, Matt Wiswell, and Basit Zafar. It's an old paper, like a paper we've been working on for a while, and we basically just finished this major revision. So I'm very excited to share with you kind of this newest version and to get feedback on what we've done with it since then. Okay, so the point of departure for this paper is just the observation that, when people look for jobs, their expectations about various objects play a central role in their decision-making. So typically a common assumption that's been made in the literature for a long time is that beliefs about various objects, today we're going to focus on the probability of receiving offers and the value of offers that people receive. But typically the assumption is that people have correct beliefs about these. So they, the models that they work with are typically under this complete information type of benchmark. But of course, making that assumption could be problematic for several reasons. First, you may be missing some frictions that are important for understanding behavior and welfare that are, beyond typical search frictions. So by that, I mean information frictions. And second, you might have this issue of biased inference if you can't, if you're assuming that the model is one of complete information when underneath it, it's actually one of incomplete information, then that may bias your parameter estimates because of model misspecification. Now, it's not that, I don't think it would take too much to convince people that expectations are not necessarily aligned with reality when people are making their labor market decisions. So I think the reason that we've gone with the complete information assumption typically is that they're, introducing expectations and learning into these frameworks would require a lot of things from the data that are typically difficult to get, although they're becoming much more prevalent. So what we're going to do in this paper is use panel data from the Survey of Consumer Expectations at the New York Fed to think about heterogeneity in expectations as well as accuracy in those expectations. And we're also going to use the panel dimension to investigate the degree of learning from labor market experiences about the objects that I mentioned earlier. So again, we're going to focus on arrival rates, so probabilities of receiving offer and the value of offers that people are going to receive. After we analyze that data, what we're going to do is estimate a model of labor market search where we have imperfect information about mean wage offers, and the new part is adding in the incomplete information about the probability of receiving an offer. And we're going to have learning rules that are just disciplined in an ad hoc fashion by the data that we have from the SCE. And then with that model, we're going to do three things or ask three questions. The first is, how well does this model fit the data relative to a model that just assumes complete information to begin with? So what we would typically do. We'll ask if our inference is biased, if we just assume complete information rather than taking into account these expectations. And then we'll use the model to study welfare consequences of information frictions on the value of offers received, as well as the probability of receiving these offers. So let me jump right into the data. So many of you are familiar with this New York Fed survey, but for those of you who aren't, it's a monthly online survey. Basically, they started collecting it to get expectations about aggregates like GDP and inflation, but for our purposes, there's a labor market ad hoc that's attached to it, which comes not every month, but every 4 months. So we have a bunch of labor market questions. There's a lot of interesting stuff in there, but what we did was add questions in March 2014 that relate to experiences and realizations. So basically, we're going to have a panel data set where we ask people expectations about future offers or the probability of receiving an offer. And then because we have the panel, we can follow up and see how those expectations relate to the actual experiences that people have. And then also kind of think about how the learning happens in the labor market. So in the interest of time, let me skip through this, but the sample pretty much looks like the CPS, except it's a little bit off based on education, which we'll come back to later. So the CPS, so the SE is typically a larger share of them are highly educated relative to the population. So let me show you the key survey questions that we're going to use. For expectations, we have questions about what people think is the percent chance they'll get an offer, at least one offer from another employer. And we make sure to remind them that the offer is not necessarily a job that they will accept. So we want to elicit just offers in general. And then we ask them also to think about the job offers that they'll receive and what the average annual salary will be. So this is going to be, offer arrival probabilities and salaries. For the realization questions, we actually ask people how many offers did they receive in the last 4 months. Was someone saying something? No. How many offers they received in the last 4 months, and then we asked what was the annual salary of the job offer that they received. Okay, so here's just to show you kind of what the data look like. If you look at the averages, here I'm splitting it all by employment status, and we're looking at average expectations for these various objects that we have. Nothing too surprising here in the sense that, unemployed workers expect to receive, have a higher probability, place a higher probability on receiving an offer. That's exactly because they're searching naturally. But I think the more important thing here to highlight is that if you look at the standard errors on these objects, they're actually fairly large, which is just one way of seeing that there's a lot of heterogeneity in these expectations about not just the probability of receiving an offer, but also the salary of the offer that they'll get. Now, of course, this doesn't, control for a bunch of observable characteristics that might already get rid of some of this residual heterogeneity. So you can also look at a residualized version where you regress these expectations about offers or expectations about the probability of receiving an offer on various observable characteristics and survey fixed effects to take into account, let's say, the fact that people's reporting might change within the survey, but also to take into account movements over time in terms of business cycles, for example. And the bottom line is that you still see a lot of heterogeneity. The R squared is still fairly low, and there's a lot of heterogeneity in expectations that's not explained by these observables. So that's to say that maybe some of this expectational heterogeneity, sure, it could be unobserved heterogeneity. That's one option. The other option is that it's just that people have different labor market experiences, and so they have learned differently, and now that brings them to a place where they have different expectations about what's going to happen.
Laura?
Yeah.
Laura, if you're going to focus so much on the standard errors on this thing and given the sample size and everything else, how much have you guys kind of pushed on how much may be reporting error, measurement error, so on and so forth, especially since zeros are such a big deal here?
The truth is we haven't really done anything on measurement error at all. We've thought about, there is a way you can introduce it in the model very easily, and I can talk about that later. Basically try to estimate how much measurement error there is in the data using some additional moments, but we haven't done anything with that yet. And I should say,
if you weren't going to focus so much on the second moments, I'd say, okay, there's some measurement error, life's going to move on. But if that's going to be the focus, I get a little concerned given what I know about the SCE.
Fair, yeah. So we're going to be everything. We're going to use data pooled from 2014 basically until the latest data that we have. But I agree with you. There's probably more we can do, at least in terms of putting into the model to put an upper bound in it. What we are going to do is take the unobserved heterogeneity seriously so that we don't confuse unobserved heterogeneity with errors in information. But I think the the measurement error is a similar issue that maybe we could do a bit more on. Okay, so if you look at, let's just look at what what we're calling like biases in these expectations. So here on the left-hand side, we're looking at expected value of the offer that you would get within 4 months against the average value of the offer that you actually get within the last 4 months. And then on the right-hand side, we're looking at the probability of receiving an offer and expectation against the actual, probability of receiving an offer. And this is within binned groups based on the x-axis variable. So in terms of expected average offers, it actually looks like people on average are getting their expected values correct so that they kind of know what the value of the offer is that they'll receive. But if you look at the offer arrival rate, it looks as though individuals are kind of biased upward in that, they might expect a probability of 1, but in actuality, it's something like 0.4. So this is not, this has been documented in other papers when looking at expectations for job finding rates, which is a slightly different object, but for job finding rates of the unemployed, here this is actually mostly for employed workers, which is the majority of our sample. Now, the reason I say biased in quotes is because you'll see that actually once you filter this information through the model, it's not going to be necessarily clear or obvious that this data here has to translate into an optimistic bias in offer arrival rates, or in fact that people have correct on average expectations about the offer that they'll receive. It's going to be important to kind of filter this data through the model, the structural model that we have, and I'll come back to that later.
Sorry, Laura, just a quick question. I'm thinking, if you tell me what's the probability that I get an offer, I want to think about that I could get an offer or that I would get an offer. Like if I'm not really searching, asking, talking to colleagues, maybe I won't get one. But if you ask me if I could get it, maybe I feel like I could.
I think you raise a really good point, which is actually why in the first version of this paper, we didn't really, we analyzed the offer arrival probabilities, but when we went to the model, we didn't really use them because we were concerned about what is this question really asking about. It feels a little bit safer to be like, what's the value of the offer? And then you see the value. Here, there's issues about search behavior. Are they saying like, if I searched as hard as I needed to for over this whole interval, how many offers would I get? Is it conditional on no search, and so on? So the answer is we don't know. The question literally asks what I showed you on the previous slide. And that's part of the reason why the model is going to be important for interpreting this, because we're going to have within the model, we're going to have search behavior. And I'll be very clear about where we're putting what their expectations are taken over. But I think it's a little bit unclear, and that's why you kind of need a model to parse through it. Shu? Hi, Shu.
Hi, Laura. So I guess similar to Paolo's question, but would the graph look the same if you did condition on whether they search? I guess like if you condition only on unemployed individuals, because this seems to mix in both employed and unemployed, if I understand correctly.
Yeah, it doesn't actually matter. Like the search behavior doesn't make it go away.
Okay, thanks.
Yeah, but yeah, let me come back to it when we get to the model. I'll show you exactly where we're going to end up putting the bias in. And it's not going to be on anything related to like returns to search or things like that. Okay, now even so, if you look within this average expected offer, deviation of actual offers that you get relative to what you expected, there is actually even, despite the fact that on average people it looks like they get it right, even so, there's a lot of heterogeneity around that average. So some people are kind of, let's call it over optimistic. You could interpret this as people being over optimistic or over pessimistic. Again, we put this as a shock because exactly through the lens of a search model, this could be entirely consistent with perfect information where they're just getting some realized offers that are kind of from the tails of the distribution. So we don't want to say that this represents imperfect information here, but it's possible that it does. But again, you need a model to kind of parse through this figure as well. In the paper, we have more details about, trying to look at how these things correlate with observables and whether or not you're searching. But in the interest of time, I'm just condensing it to the kind of main figures that are important for what comes next. So jumping now to learning, we're going to look at how people update their expectations about the value of offers they receive, as well as the probability of receiving an offer conditional on receiving an offer. So here, what I'm showing you is on the x-axis, you have the shock, and then on the y-axis, you have the change in offer expectations. And what you see is that people are, certainly updating their offer expectations in response to receiving an offer. And so for every $1 that the offer is above their expectations, they revise their expectations upward by 47 cents. If you look at changes in expectations for the probability of receiving an offer. Here I'm actually showing you two separate lines, one for those who did receive an offer in red, and one for those who did not receive an offer in blue. But kind of a similar picture emerges that if people, receive an offer or do not receive an offer, they actually kind of update in a similar way. And they do put a lot of weight on their prior expectations, regardless of whether they receive an offer or not. And then it kind of makes sense that those who do receive an offer, on average, update their expectations about the probability of receiving an offer to a higher number than those who do not receive an offer. I see some hands.
Maybe I'll go first because I don't know who's going to jump in first. Yeah. So you can defer this question to when you get to the model. But one thing I'm curious about is that we're using this to say that, oh, this is a way that we see that they actually learn and update their offer expectations. But suppose it was complete information. And the reason why I raise my offer expectation is that, well, now I have an offer in hand. My outside option has increased. And so that's why my offer expectation goes up. It's not so much about learning, it's just that I have changed my outside option value. So
Yeah.
we can defer this to later about how you want to think about it, but that's just
So I can answer it now because we're going to interpret it as, the information story, not the outside option story. Probably to answer your question, what we would need to do is, and which we've done, is show these updating rules, controlling for changes in labor market status or changes in wages that might occur, right? So like if someone at the same time gets an offer, maybe accepts it and then has a different outside option, we want to be controlling for that in our updating regressions, which we have in the paper. So this is sort of like not showing that in this simple figure, but that is something that you can control for. And then once we've controlled for that, we're only going to take the part that's kind of not explained by people updating, their employment status or their actual salaries. The question by Lucas. Oh, two Lucases. So Lucas with a C.
Oh, sorry, I think I was just first. Yeah, so I just have a question about big picture estimating. How easy is it for humans to estimate probabilities versus means? I think that for me personally, like a mean, I could be wrong. Basically the error could be symmetric, like I can be wrong to the upside or it could be wrong to the downside. So there's at least some very stepping back from everything we know about economics, just some pure math reason for why that might be more centered. Whereas probabilities are 0 and 1. So bounded between 0 and 1. So there's often there's no corresponding upside to compensate for a downside. So for example, if you're asking me, like I'm sure most people in this room have been asked by someone over the last year, what do you think the mortgage rate is going to be in a year? That's something we can be wrong in both directions. So that might be easier to get right. Then what do you think is the probability that they'll be lower over the next half year? And I'll say, yeah, I'm pretty sure. So I guess in your corresponding data, that would be an 80% sure. But then if it doesn't happen, or if the true probability is 20%, that's just very hard for me to revise my guess. And I was just wondering, is there some behavioral economics literature just on humans estimating probabilities as opposed to means in general?
I actually don't know the answer to that. Given what you described, I wouldn't be surprised if there was. But I think for us, I don't think that matters for us in the sense that might be true, and we're just gonna read these expectations and revisions off the data directly. So it may be true that part of the reason that we get this kind of symmetry that you're talking about is just because we're looking at values rather than probabilities. But I think that's fine for us as long as, we've properly accounted for it within our model, then I think it's okay. But I do think it's interesting to think about are these, what are the reasons that you get that? One other thing I'll point out is that we have also the number of offers, which may be a little bit less subject to what you're talking about rather than just these probabilities, and you kind of see the same thing. I hope this back button works. But basically, if you ask about the number of offers, they say 5, and then in actuality ends up being 2. Of course, subject to the same issues that Paolo raised about, the other question about probabilities as well.
Thank you.
The other Lucas. Hi, Lucas.
Hi. I was just wondering, do you have any kind of notion of heterogeneity of this updating for example, by occupation or by industry? Because I guess kind of I mean, if you come to this, feel free to postpone it. But
Yeah, we looked a lot originally at whether there was heterogeneity and like, you know, the size, especially for the mean offer, whether it was heterogeneity by the size of the shop, whether it's positive or negative, by age, and there just really actually didn't seem to be much there. So you'll see we allow for, when we go to the estimation, we'll allow it even to be different. Ultimately, we'll allow the learning rule to differ by education because we're going to estimate the model separately for the two education groups. But even there, you don't see a huge difference in terms of how updating occurs, at least on the value of offers. I think it looks pretty different for the probabilities of receiving an offer. And I'll show you that.
Let me ask a quick follow-up maybe. So the heterogeneity I had in mind was, do you see differences depending on how much wage dispersion there is within a given industry or occupation? So like,
Ooh.
This what you showed before, that should potentially vary, right? Like if there's a lot of wage dispersion, if I get a high offer, that might just be a coincidence because I'm in the tail. If there's no wage dispersion, I get a high offer, then I'm learning a lot about the mean because that essentially is the mean. So kind of like in a Bayesian motion, basically.
We didn't look by industry, so I don't know the answer to that. But that's a good point. We can look at that. Thank you. Okay, so to just recap before I move on to the model section, basically we think there's a lot of heterogeneity in expectations. It's not all explained by covariates. Some of it may be unobservable. Some of it may be, different labor market histories, which lead to different expectations, which is another form of unobservable characteristic. Some of it could be the measurement error that Jason mentioned, which we need to maybe think a little bit more about. There seems to be an upward bias if you look at the raw data and take it at face value in terms of these probabilities of receiving an offer. Expectations look on average correct, but again, both of these statements, I think it's important to look at this data again through the lens of the model, exactly because you can't really say whether there's a bias or not until you take a stance on what the true parameters are that people are facing. There seems to be learning. People do update their expectations about both the values of offers and whether or not they'll receive an offer based on whether they get an offer. And it seems to be, there doesn't seem to be much heterogeneity, though I haven't looked at exactly through industry variation. Okay, so let me jump to the model.
Laura, just real
Yes.
quick on the model.
Yeah.
You guys don't say anything about duration dependence here, and I guess you have to think about it a little more broadly in terms of searching among employed versus non-employed. But if you think, the large literature on duration dependence, there's some kind of level of discouragement there. Underlying discouragement in job search is probably reflecting changes in expectations about the probability of an offer over time. So you'd think that as a function of the duration of search, the change in these belief expectations may be correlated or should be correlated with that as well, right? And that people that have been searching for a long time and don't receive an offer may have updated their expectations a lot more and corrected them a lot more than people in the first couple months of searching.
Yeah, I think theoretically that makes sense to me. And I think through the lens of the model, it is true that depending on how long you've been searching, your updating is going to look different. But if you just look at those slopes, those raw slopes that I showed you on the updating by whether you did or didn't receive an offer, they're actually pretty similar, surprisingly.
Yeah, but you don't know where there's unobserved heterogeneity in those slopes, which is going to be how long people have been looking,
right,
or if they've been looking, right? That's my point. So
yeah,
maybe
yeah. So
control for that, those slopes might look different.
Yeah, so we have in the paper, which is not posted, we do have the version where we have covariates. I know we have unemployment in there, but not necessarily the duration, which might get more directly to your comment.
Laura, can I ask you a quick, related to the heterogeneity question?
Yeah.
So do you see the folks who are kind of, I guess, maybe seemingly pessimistic at the beginning, do they accept job offers earlier? Like when you follow up with them four months later, are they more likely to have accepted an offer?
I mean, I'm hesitant, or we're hesitant to go there with just the pure data again, because we have to take a stance on like to call someone pessimistic, I need to say, here's your expectations, which we have.
Mhm.
And then the only other thing I can see is their real, let's say in terms of the value offers, I see their expectations, I see what the offers they actually got. And I see it maybe once, at most twice, with the panel that we have, realistically.
Yeah.
And so I could take that very seriously and call that pessimism, but it could also just be a random draw.
Mhm.
And so we're just hesitant to like
I see.
directly look at those shocks
You don't feel
as,
comfortable enough controlling for what you have.
yeah,
'Cause
or
I guess
interpreting
that's
it
like-
really as a deviate, or interpreting it as an error in information rather than just random draw or unobserved heterogeneity, for example. But we have looked at like correlates of the shocks with other things, but what specifically are you?
I mean, I don't know. I guess one of like the theory, this relates to the duration dependence question, I guess also is, like Burdett has all this old paper that like, it's not that people's reservation wages are actually falling over time. It's just that you're getting selection, right? The people who thought the distribution was worse end up sort of dropping out early. They accept an offer because they think it's great. Whereas the people who are sort of overly optimistic wait around and slowly learn over time that they were too optimistic.
Mhm.
And so just understanding like the composition of who stays in, and you have data, I guess, where you're talking to people who are both employed and unemployed. It's not like they drop out of your sample. So I was just
Right.
wondering if you could think about.
Yeah,
Anyway,
so I mean, we can definitely do that. Again, subject just to that caveat that you would have to like start, if you just use the raw data, you have to start from assuming that those 2 points tell you that this person is pessimistic. And the reason I'm hesitant, you'll see, is when I show you the distribution of errors once it goes through like our model,
yeah.
we're not going to actually have that over bias in
Okay.
arrival rates,
All
for
right. I'll wait.
example.
Thanks.
David?
Sorry, I think you guys have kind of talked enough. I was just gonna say that something fun to do actually would just be to, because next period after they've updated, they've actually been searching for a year, period longer. And so, simple duration dependence kind of curve, like true duration dependence, not heterogeneity, would say that's even more surprising because you're less likely to get another offer. So,
Yeah. Fair. We really haven't done much with the duration dependence component. I mean, partially getting back to the sample size issue, the unemployed, it's fairly small. Most of our sample is employed workers, but I think we can do more on that. Okay, so let me walk you through kind of the framework that we're going to use to interpret this data. So the basics, like the simple part, is we're just going to have a random partial equilibrium search model with search on and off the job. Search is going to be endogenous. So we're going to work in discrete time. There's going to be an exogenous separation probability delta, an exogenous offer distribution. We're going to assume to be offers are log normal. These offer probabilities are going to be endogenous. So we're going to allow people to choose whether or not to search. So it's just going to be a 0-1. And searching and employment status are going to affect your probability of receiving an offer in a flexible way. We're going to do it in a way that is going to be disciplined by the data. What does search allow you to do? It improves your offer probability naturally, but it's going to be costly. So people are going to be drawing these search costs every period from this distribution H. And then workers who are unemployed have this value of leisure V, and there's going to be a moving cost for changing jobs, which is going to be M. Okay, nothing fancy here because I haven't said anything about the information structure. So the assumption we're going to make here in terms of expectations relative to the truth is that there's 2 dimensions that workers have expectations over that are not necessarily equal to the true underlying values. One is going to be the mean of the offer distribution. So if the distribution is normal, or if log wages are normal with mean mu and variance sigma, we're going to assume that they don't know mu. So that's why I'm putting everything in red that they don't know. And they're going to have some beliefs at day t about it given by this mu hat t. So this is kind of like, at this point, this would be basically like Burdett-Vishwanath framework. Now, in terms of the likelihood of receiving an offer, we're going to assume that the probability of receiving an offer depends on whether you're searching and your employment status in the following way. So it's going to relate to whether you search, whether you're employed, and possibly an interaction between the two. And gamma is just going to represent this constant. So we're going to assume that workers, do not know gamma. So they don't know this variable here, but they know what the rest of the parameters are that govern this probability of receiving an offer. And they're going to have these beliefs, gamma hat t at date t about gamma. Now, this is sort of like, okay, why did we do it this way? There's actually a reason for this. One is that we want to, when we go to estimate the model, the key thing that we want to be able to do is allow for a lot of heterogeneity, both observable and unobservable, in the offers that people receive and the probabilities of offers that people receive. But at the same time, we also want there to be expectations that possibly deviate from those true underlying parameters. So what by putting in the expectations that people have over this constant here allows us to do is, we can have rich heterogeneity in terms of true underlying gammas. And as you'll see, we'll allow it to differ by lots of observable characteristics. And then we have one, people just have an expectation over that value. And that's going to be a simple way to introduce these expectations into a model that doesn't like blow up the state space in a crazy way. That's, and not only that, for the values of offers, we're also going to introduce heterogeneity, both observable and unobservable inside this the mean value of the offer. And we just kind of have to make an assumption about what they know and what they don't know. So we struggled a bit with thinking about what are the actual things that people know and don't know. The truth is, I don't think they really know much of these parameters, but this is basically a starting point for thinking about this question, is how I would think about it. Okay, so we're going to summarize these beliefs at some date t by this omega. And I see some hands. So let me start. I guess Paolo has a question.
I think Lucas was first.
Oh, Lucas?
Okay. I was just wondering, does this implicitly also kind of assume that households are uncertain about the marginal benefit of search? Because I guess the functional form gives interaction, right? So which direction does that go? So is it, if I have low beliefs about gamma, am I discouraged? So this is self-fulfilling, or am I encouraged to kind of...
Another way to say what I think you're saying is if you actually, right, obviously the derivative of this guy with respect to search depends on gamma. So if you're uncertain about gamma, you're going to be uncertain about the returns to search. So that is true. Which direction is it going to go in? That I don't know off the top of my head, but it's a good question in terms of the returns to search.
I guess it would be kind of interesting to see whether this is kind of self-enforcing or not. So if I believe that gamma is low, if I then searching less, then my realized arrival rate will be lower. So there's kind of some self-fulfilling prophecy there, maybe.
Yeah, it's interesting because we convert everything, including the data which we have on expectations about the probability of receiving an offer. We just convert it to construct the log odds. So then we were doing looking at the log odds of this thing as a linear function of these objects, and we were kind of not actually thinking about the benefit that looking at it this way gives us, which is that you can interpret this as uncertainty about the marginal returns to search. So yeah, that's a good point, that we should see which direction that goes in overall. That's right. Paolo?
I might have the same question. I'm not sure if it's exactly the same, but I'm thinking exactly whether this functional form gives you room for experimentation. Like, for example, if you were uncertain about phi, then by putting the effort or not, you learn more or less about the parameter, or whether this gamma being a constant make it so that you learn in the same way regardless of your effort and problem status. I think it's a kind of a property. It's a property of the process you may want to know to understand whether the room that role for experimentation is there, or whether you want to actually eliminate that.
I'll tell you right now, there's not going to be any role for experimentation because we're going to have myopia. So at least in the model, we're going to rule that out. Previous versions, actually, we've solved the version where we don't assume myopia. It looks actually, in terms of decision rules, it looks so similar to the model under myopia but it just takes 20 times longer to solve that we just
I can see. Okay, thanks.
Leon?
Yeah, I have a question about the true offer distribution. So here we're assuming there's no cyclical component. So I'm trying to also recall the data periods. You said 2014. Is it like in terms
Yeah.
of the business cycle part?
So what we're gonna have to do, so that's right, we're basically taking out anything related to the cycle. And so what we're doing in practice is when I show you how we do the estimation, we're gonna just kind of take out a cyclical indicator and remove it. And including, so both in the actual offers that people receive, but also in terms of the learning, we're just trying to like filter that out. I think there's a lot of interesting questions that one could think about that introduce the cycle back into this kind of framework, but we're not going to have any of that here. So the assumption is that like the environment is stationary. You're in particular, your mu's not moving over time, and you're learning about, you know, that particular object that is unchanging. But again, we're, you know, residualizing with respect to a whole bunch of things, observables, age, and so on, and including the, and the cycle as well. Yeah. Paolo, your hand is still up. I don't know if you have. Okay, so Shu.
Oh, this is just a clarification question because of I'm confused by the notation. So am I only learning about the point estimate? Because usually when I think about beliefs, we have a distribution of beliefs. It's not just the mean, but it
Yes.
seems that I
The
only
answer
need to
is
care about
yes.
omega. Okay, sorry. Very
Yeah.
good. You answered
The
my
answer is
question.
yes.
Sorry.
And so it's not that you have a prior with a mean prior and a distribution around that mean. It's just the point estimate, and you have an expectations that it's going to be that point estimate for sure. That makes sense. You'll see it in the value functions. Okay, so here's the timing of the model. So you start with some beliefs summarized by omega. There's going to be production and search, possible exogenous separations if you're employed, and some job offer arrivals after that if you don't separate. You update your beliefs, and then you make an accept or reject decision. But going back to Paolo's question about experimentation, we're going to make the assumption that when they make their decisions about accept or reject, they're just going to, you know, they're myopic. So they think this gamma's omega t is going to stay the same forever. Previously, we allowed this to affect, you know, whether they accept or reject or whether they tried to search more or not, but it didn't make a huge difference. So we sort of just kicked it out. The learning rules, we're going to just be very reduced form and ad hoc. I think that's actually something that we're trying to build, you know, that we think is a feature and a plus of this framework is that we have enough data to discipline this very, very reduced form learning rule rather than putting tons of structure, right? Like starting from the point where we say people don't seem to have accurate expectations, but let's assume that they're Bayesian and they can solve that whole problem. No, we're going to take the approach where we just say, look, they're just learning in this way that is disciplined by the data. It's completely reduced form, and it may or may not be consistent with Bayesian updating. Okay, so your belief tomorrow about your value of the offer is going to be some weighted average between your prior and the offer that you receive, and it doesn't get updated if you don't receive an offer. Your belief about gamma is going to be some function of your prior, and then some additional updating parameter, which relates to whether you do or don't receive an offer. Liangji?
Laura, I have a question.
Hi.
Is it possible for people to get a multiple offer during the same period?
No. I mean, in real life, yes. And in our data, it definitely happens. So what we're doing is taking the max offer and using that as the single offer.
I see.
But we don't like do anything explicit with, you know, you could be more explicit about like the number of offers they receive and so on, but we're just going to, you know, keep it simple and go with the maximum offer as the single offer they get.
Right. Maybe I guess maybe it doesn't make a difference, but I thought maybe if I get more offer during the same period, I might be better in some sort of a measure in my updating of the average or
Yeah, so
something
the
on
question
my
is how the number of offers that people get affect like the learning rules that we run. So in all the stuff that I
Yes.
showed you in terms of updating, we're always using like the maximum offer that they receive. So the
I
question is
see.
whether that slope changes with the number of offers that people get or not.
I see.
My recollection is not, because again, there wasn't much heterogeneity in that updating, but I don't remember off the top of my head exactly the one for the number of offers, for example.
Got it. Thanks.
Okay, so the perceived values of unemployment and employment are going to be given by the following. So you're going to, the value of unemployment that's perceived by the individual with some beliefs omega t is going to be the value of leisure minus the cost of search if they are searching. So this S has to be either a 0 or a 1. The returns to search are that it's going to increase your probability of receiving an offer. Remember here, the 0 is just a dummy for whether you're employed or not. So a 0 means unemployed. And then they make a decision about whether or not to accept the job based on, again, I'm building in the myopia assumption already here, based on their current beliefs omega t. And based on, so I'm highlighting here in blue the things that actually are a function of their beliefs, right? So it's the arrival rate of offers depends on their beliefs about gamma, and the value of the offers that they get also depends on their beliefs about mu. And if they don't get an offer, they just remain unemployed. And here I'm just taking the expectation over the search cost because I'm just writing these values from the ex ante perspective. So before they actually realize these search costs. Shu?
So I
Oh
guess-
yeah, so going back to your point, there's no double integral here over the prior distribution. Is that what you're going to ask about?
No, slightly different, sorry.
Okay.
So if you don't mind going back to the slide on the learning rule. So I guess one thing, and you can correct me if I'm wrong, but if I look at this learning rule, it seems as if the history of offers and the salary offers, right? The value of the salary offer, as well as the history of the number of offers I've gotten, don't really play a role here because it's really just a function of last period and the current offer that I get, right? And so how do we reconcile this? Is it because in the data you really see that the history of offers don't seem to matter for people's expectation of today's offer, right? Because it sort of gets revised a lot and it looks like it could be very volatile, this expectation.
Oh, it is, yeah. Actually, in particular, like what's going to happen if you just simulate this thing forward is like they converge on average to the truth, but they're always forever going to be bouncing around the truth. You're absolutely right that it's not that your updating depends on the full history. In principle, that is something we could check with the panel dimension, because we have at least 3 periods for some households. I guess we started with this because if you were to take the Bayesian approach, you would basically have something that looks like this, although you're right that like this updating parameter would depend on the variance, which basically the variance of your prior, which would basically encode the whole history of search. That's where we started from, from the trying to nest Bayesian. So I think that's sort of like just a remnant of that. But we could empirically look to see if like just controlling for your latest expectations is enough to capture all of the learning. Okay, and then there's going to be a similar value for employment. I don't think there's anything special to highlight here. It's just the same thing, the same logic as the employed, except we have this moving cost in case you do move. Okay, so I have to speed up a little bit. So we have reservation wages are going to be defined implicitly in the natural way, and then we're also going to have these search cutoff strategies. So below the search cutoff, you're going to search. Above it, you won't. There's going to be one for each wage and belief. This myopia assumption is also giving us something that we didn't have in the Fuller model, where we allow you to like update first and then make a decision about your acceptance strategy, which is that it's a little bit more difficult to prove that reservation strategies exist. And so under myopia, that's no longer a problem because now we're kind of like back in the standard world where everything looks nice. Okay, so the complete information benchmark can basically be subsumed into this model by making a couple assumptions on the parameters. One is that you're at the truth, so you start your expectations at the true value for yourself. And then the updating is such that you just stick with the prior. So that would be the complete information benchmark as nested in this kind of incomplete information learning environment. What does information or lack thereof do? It's fairly natural, right? If you're, let's say, over optimistic relative to the truth, your reservation wage is going to be higher coming out from unemployment or also from for being employed, because you think that the option value of weighting is high. And so you're going to reject offers that if you otherwise knew the truth, you would actually accept. And then vice versa for pessimism. So if you're pessimistic, your reservation wage will be lower. You'll accept jobs that you actually, you know, in the complete information environment, you actually wouldn't have accepted. And a similar logic holds for this search effort. So basically what this lack of complete information does is it just messes up your optimal policy rules and leads you to accept jobs that you shouldn't take, or maybe search too much or search too little. Okay. So how are we going to estimate this thing? So I mentioned already before that the key thing that the key problem with this thing in general, when you're thinking about expectations and realizations, is that you have to take a stance on what people's actual true underlying parameters are, and you have to figure out what's the correct benchmark to use. So one option is just to use, people who look similar, at least observationally, and just take the average of, let's say, the offers that those people received, and then call that the actual true underlying offer distribution for individuals in that group. But of course, there might be some unobserved heterogeneity even within that group of people defined by observables. And then if you don't model that unobserved heterogeneity, then you're going to be misinterpreting deviations or of expectations from the quote unquote truth as errors, when in fact it's just that they are different people based on unobservables. So we want to take the unobserved heterogeneity seriously. And the way we're going to do that is as follows. So we're going to first take a parametric form for this search cost distribution. It's going to be exponential. There's going to be a mean that governs the cost for employed and a mean that governs the cost for the unemployed. And then basically we have to estimate all of these parameters. Just to summarize or refresh, we have some standard labor market parameters. The red ones are the ones that are things that people have to learn about and don't have complete information over. We have the parameters which govern returns to search, the updating rules, and then we have the distribution of beliefs we have to pin down, as well as these like preference parameters and cost parameters. So some of the values we'll just take directly from the data. For example, the separation probability, we can just pull directly from the data once we've separated by college and non-college samples. And again, we can use the learning rule within those college and non-college samples, residualizing with respect to everything else that's not in the model, and then just plug in what these reduced form learning rules are from the data. So that's what we're going to do for those. For the unobserved heterogeneity and the actual true underlying offer distribution and arrival rates, what we're going to do is the following. So we have this assumption that the offer distribution or log offers are normal with some true mean mu I that people don't know about. And then we're going to assume that these individuals can be one of k unobservable types. So there's just going to be, we're basically going to do an EM algorithm to estimate the maximum likelihood of observing the actual data that we have on offers that people get, in addition to the value, whether or not people receive an offer plus the value of the offer conditional on receiving an offer. So essentially there's going to be k different types. Sorry, this should have a k on it. Your type basically shifts the offer mean. It's unobservable to the econometrician, but observable to the individual. In expectation, your offer is going to be equal to some observables with some estimated coefficient that we can estimate directly off the data. So in this XIT, there's going to be things like age, gender, occupation, and so on. And then this is going to reflect kind of any kind of unobservable heterogeneity that's correlated with offers that's not correlated with these observable characteristics we control for. The probabilities of receiving an offer, we're going to do something similar. So we're going to allow it to depend on observable characteristics, age, education, and so on, plus these search decisions and employment statuses. Again, your expected true underlying gamma then is going to be equal to, it should be this alpha hat XIT plus the rest of this stuff here. The reason I didn't write this here is because it relates to how we're going to back out these expectations, right? So let me just try to be clear about how we estimate the expectations off of these equations. So if the assumption is that actual offers or expected offers are going to look like this, which we can estimate directly from the data, just run a regression of offers people get on observables, then we can get this alpha hat mu, and we can, predict what people's true offers are. If I have in the data people's expected offers, then I can just take the expected log offer, subtract it from my predicted offer, and that gives me the individual's kind of error. Similarly for the probability of receiving an offer, in the data, I observe people's, reported probabilities of receiving an offer. I can turn that into a log odds. And because I've estimated this equation, then I can construct this gamma hat IT as whatever the predicted value is here, minus the reported log odds, net of the components that come from search, employment status, and their interaction. The reason I take those out again is because the assumption is that expectations are over that constant term, and the model is already going to capture kind of their search and employment status. Yeah, David.
Yeah, so I might be misunderstanding a lot, but one of the nice things about writing the learning process the way that you did it related to how you're going to take expected offers from this regression and what they report, right? So you're actually observing them after, living for some period of time in the world. And if learning were declining in updating rate over time, then you wouldn't probably want to do what you're doing, right? Because then you would have to relate those errors and expectations to the length of time over which they've been searching.
Like in here.
Yeah. But the fact that you're taking everybody's like regression prediction minus what they say, and that's the error, that's consistent with like learning at the same rate every period.
Yes, except I didn't put in X, like how long they've been unemployed, for example. But that would suggest that I should put that in.
No, I was kind of thinking like by not having that in, that's more consistent with not doing kind of the full Bayesian where your variance declines with the length of search.
Oh, okay. Well, then good. I'm glad you're on board. But
yeah. I was trying to point out like you.
But let's talk about that maybe offline after. Okay, and then once we have their people's expectations and the true underlying things that they're trying to update their beliefs about, we do this two-step estimator. So we run those regressions, then we do MLE to get these unobserved types and the type probabilities using the EN algorithm. The distribution of expectations, we pull directly off the data, given what we've estimated in those two regressions. And then the remaining parameters, which are just these preference parameters and the search costs, so we're just going to do via method of moments, where we're looking at moments that are informative for these, so like transition probabilities and search probabilities. Okay, I'm going to skip through. So so we estimate the model for the college sample and the non-college sample, both under the model with incomplete information and learning and the complete information benchmark. Naturally, the parameter estimates you get in the two are different. You can fit the data perfectly in both models, which we do. But importantly, so to answer the first question that I mentioned in the beginning, so is inference bias if we assume complete information? The answer is yes, not surprisingly. But it relates to what you estimate is the underlying distribution of errors. So what I'm plotting for you here is the errors for, I'm separating out the employed and non-employed. So I'm separating out college versus non-college samples. So the blue is the college sample, the red is non-college. This is the top panel is probability of receiving an offer. The bottom panel is the value of the offers. And positive numbers you should interpret as people being pessimistic. So what you see from these figures is if you look at, let's say, like the median values for these, people seem to be pessimistic almost on every dimension. Of course, there's people who are, there's a distribution of these things, but on average, people are relatively pessimistic. So what does that mean? That means if you go back to, when you try to estimate these underlying parameters, when you're trying to fit transition probabilities, not taking into account the fact that on average people are pessimistic is going to lead you to, underestimate these parameters. So just to give an example, if workers are pessimistic, what does that mean for reservation wages? They're going to accept jobs, that they otherwise wouldn't have accepted. And that means their transition rates are going to be relatively high if you were to use like the complete information benchmark estimates. So in order to bring the transition rates back to what they should be or what they are in the data, then you actually have to raise these, let's say the value of leisure. The same logic goes for moving costs. So this is kind of not surprising that the estimates are going to change if you just ignore these expectations. A second thing we do is ask, going back to the 3 questions I posed in the beginning, how well does this model fit the data relative to a model that assumes complete information? In order to answer that, what we do is look at the model's predictions for reported reservation wages. So we have the 2 models, complete information and our model with incomplete information and learning. Both models give us policy rules. So reservation wages as a function of beliefs about mu and gamma. And we can just use the policy rules to interpolate people's reservation wages or what the reported reservation wages are, and then correlate them with what they actually report in the data and see which one does better. So what you see here, what I'm reporting for you is like our baseline model and then the model with complete information. And we're looking at this correlation between the reported reservation wages in the data and the ones implied by the model. What you should take away from this table is that our model with imperfect information does better. Why? Exactly because if you look in the data, these expectations actually matter a lot for reported reservation wages. So what you see is that the correlation coefficient is much higher for our model relative to the model with complete information, and especially so for the non-employed, which makes total sense because the reservation wages for the employed are dominated by whatever their current wage is, and that's present in both models. Okay, the last thing I want to do in the very short amount of time that I have remaining is, or just give you the gist of what we do in terms of answering the 3rd question, which is, what are the welfare costs of these information frictions? So in order to answer that, what we're going to do is the following. We're basically, so this is literally the value function I'm solving, which essentially says take the policy rules from the underlying model, which assumes that, people are making decisions based on their expectations. So these are the policy rules coming from the model with expectations, but then plug in the actual values for, let's say, the arrival rates and the offer values that people are getting. This is the same thing as simulating an economy with the old policy rules, but with the true offer arrival probabilities and values governing whether people get offers and the values of offers they receive. It's just that this is like an ex-ante calculation. So this is going to give us what kind of welfare is in the world with imperfect information, and then we can compare it to the world with perfect information, which would just be the case where the omega t's actually align with the underlying truth. So that's basically what we do in the paper. So we report like the change in welfare going from the complete information benchmark to the baseline model, which is the model with including learning, versus a model where you actually shut off learning altogether and just assume that people are off forever. The way you should interpret this number is like, this is literally the difference in PDVs. And we've actually, the wages that we have in our model are hourly wages. So you have to do a bit of a conversion to get this to annual earnings. But I've done that for you here. So for the non-college sample, you get a welfare cost at something like 3% of annual earnings if you wanted to do a one-time payment, which is actually fairly low. But actually, if you look at the college sample, it goes up to 60%. So it's actually quite large. So people would be willing to pay a one-time payment, which is equal to 60% of their annual earnings in order to have access to this perfect information. The welfare costs are larger naturally if learning is absent, because learning gets you towards the truth, even though it doesn't get you there with certainty. And we look at the heterogeneity in welfare costs. So I don't want to go over my allotted time, so I'll conclude here and we can talk more if anyone's interested. So there's a lot of heterogeneity in these expectations. One, I think you could see in the raw data, you might interpret those as biases, but actually through the lens of the model, one example, if you look at like the probability of receiving an offer in the raw data, it looks like people are over optimistic, but actually on average, they're pessimistic once you filter it through kind of an appropriate prediction for what their actual offer should be, taking into account search behavior. People respond to their labor market experiences and put a non-trivial weight on new information. And then we have this model, which is meant to take this data seriously, which shows that inference is biased naturally. The model fits the data better than just ignoring it. And then one thing which I haven't showed you because it's still running is converting these welfare gains into search friction equivalents. So basically, how much would you have to change the arrival rate of offers in a complete information world to give you a welfare gain that's similar to what we've documented with this incomplete information? That's still running, but that's kind of another calculation we do. Thank you so much for all your comments and questions. Very helpful.
Perfect timing. Thank you, Laura. So we will open the floor to questions. Daniela, do you want to go ahead?
Yes, can you hear me?
Hello.
Hi, can you hear me?
Yes.
That's it.
Yeah.
Hi. Thank you for the great talk. My question is about non-wage amenities. So maybe you can't, but you look only at earnings, and we know that a lot of people get value from things other than wages. And this might, this would look like a gap between wages and expected wages. I'm thinking someone goes with a number in mind, they bargain with their employer to be, and they may get a little less in wage, get more time off, more research funds, or less teaching for the crowd. You don't get the right number in terms of wages, but you get the value that you wanted. In particular, you could map the distribution you have wage minus expected wage into basically a trivial distribution in values.
Right.
I don't know if you have much to say. You did mention that you have offers, you have multiple offers. So maybe you can get something from the fact that not everybody gets or accepts their max offer. I don't know if there's any
Yeah, so
information
a
you
couple things. So one, I think the issue that you're raising is only going to be an issue if there's like bargaining ex post, where they then trade off wages and amenities. So that's the first thing. So that could be happening. We could exploit, if you wanted to check that, we could look at exactly what you say, which is that we have expectations of offers, then we see the offer people get, but then to the extent that they accept offers, we can see like the resulting hourly wage. So you could check how much that lines up with like the offer that they report. But we haven't looked at that. One other thing we do have in the data, I mean, this data is so rich, there's so much in there to look at, but they do have questions on like scale questions on like how happy are you with your job, which represents more like a combination of amenities and wages.
So, I mean, with respect to this last point, maybe you could see whether the people who are in the deficit in terms of wage minus expected wage, I don't know if I'm
Yeah.
screwing it
Yep.
up, are in the high value of amenities or low value of amenities,
Right.
and the other one's in the low value. Maybe
Yeah.
this is
Yep.
some anything. Anyway, I know
Yeah, no, but I think
amenities
this
are very hard, but
I think this like broadly relates to Jason's point on measurement error too, as like what are we interpreting
And-
as these shocks if we are not taking into account these things, or even if there's just like raw measurement error. They're all gonna be, yeah.
Thank you.
Yes, Amanda?
Hey, so I'm
Hey.
interested in the employer side, and I know that this is not an equilibrium model, but I think you can still connect it to that literature and maybe provide some statistics that are useful. So there's this like Ellison idea of when you have low search costs, at least in retail markets, you want to engage in obfuscating the prices that are being offered. So even just some simple statistics on how those reservation wages change with the variance of the believed distribution can relate to that literature. Also, you can look at the ranges of wages that employers post. Like, I think people are going to ask you to relate this to these laws about wage posting, like in online ads and so forth. I'm kind of wondering if the ranges that you find in your model are close to the ranges that you find when employers have to provide wage information. They don't put like $12 an hour, they put, you know, $8 to $30 an hour. And kind of if these things hang together quantitatively.
I see. So looking at like the distribution of offers that we have in our data and how that lines up with, or how it correlates with, what was the
No,
belief?
the distribution of beliefs.
Ah, okay.
Yeah. I mean, okay, one last thing. So I don't want to make the claim that this would be true in an equilibrium model, but it seems like I was a little surprised that the actual wages lined up well with the expected wages, because we have a model with imperfect information and learning as you do. If you are expecting a wage of $15 an hour, I can offer you a wage of 14, change your expectations, and you'll be more likely to accept, you know, the lower wage, right? There's like kind of a penalty of offering you a higher than you expect, but a potential gain of offering you lower. And I know that's beyond your paper, but
no, I think it's the employer side, I think, is interesting here, and how you would think about like whether employers know this stuff and whether they can exploit it or not. We're not thinking about that at all in this paper, but I think there's like a whole another side to be explored that is worth thinking about that we don't have any information on here.
Yeah, but just, you know, maybe a few statistics to help that literature. Yeah.
Got
it.
Ben?
Hey, Laura, how are you?
Okay, good. How are you?
Maybe I missed it. Did you show us like anything about the speed of learning that you guys back out from the model? Like how quickly do people?
Let me go to it. I flashed it. You didn't see it?
I'm slowing down.
All right. So here's the thing. If you simulate this, let's say for the updating rule for the value of offers, this is basically in line, roughly it looks like the number I showed you in the very beginning in terms of the updating slope. So like if you're if your expectation, sorry, if the value of the offer is $1 above the expectation, you update by 46 cents, something like that. And then here's the result that it doesn't vary that much by college, non-college, and so on. But if you simulate this forward, what's going to happen is that on average, people are going to get to the average, but they're always going to be bouncing around. So there's never a convergence exactly towards the true value, no matter how long they're in the labor market. That's kind of a feature of this learning rule that doesn't have any kind of like declining variance in the prior, or the weight that you put on your prior. Did you want like
No, okay. I guess I didn't realize that was like a feature of the functional form you picked, is that like you never kind of converge.
Exactly. You never get there. The way you would have, you would have to build that in somehow to have with more structure on the slope of the updating rule.
Gotcha.
Which I don't think we have quite enough data yet to discipline, but like that's how you would have to do it.
Gotcha.
So I guess what I was saying is I think that's nicely consistent with the way that you treat the data, where you take the errors from the regression against the stated expectation, because you're kind of not conditioning on how long they are in the search process with that, right? And by not having the variance of the updates changing with the duration of the search process, everything's
in line. I agree with you that it's consistent. The only issue is if there to the extent that there is a slope that changes with how long you've been, then we're doing stuff consistently with like the wrong assumption.
Right.
I don't know. Internal consistency. Is there anything?
But I see what you're saying.
David likes consistency over correctness.
This is the best type of consistency, doing it the wrong.
Exactly.
I guess I'll ask. That was great. I have a very unproductive question, but which all probably have answered it, just to understand. So let's say I have a very directed search kind of Menzies C model in mind about the world, and there's a lot of
No,
heterogeneity.
you shouldn't. That's bad for this model.
Right. Yeah, right. But I guess these, can you just rationalize? I guess my naive question is, could like you rationalize all the data with the very naive view that, look, people are looking very different labor markets. Everything I see is just, everybody's a super Bayesian person. You just capture, as you said, unobserved, massive unobserved
Sorry.
heterogeneity.
Oh, I'm going the wrong way. I want to show you something that relates to that point. So I see what you're saying, that like, okay, it could be that people who have higher wages, for example, are just looking in different markets and we're not accounting for that. And so now I could be interpreting the fact that their offer differs from the average within the group that I put them in is not quite right.
While it's just competitive search mechanics, if you're really
Right.
that world, yeah.
So one thing is like, what we should do, again, for consistency, but also to like to make sure that that's not something that's happening, is I'm trying to find my slide, which has the regret here. Basically, we can always control for the most recent salary, and it is true that if you have a higher salary, like the expected offer later on is going to be higher. Now, that could be consistent with the mechanism you're saying, or it could be this unobserved heterogeneity, which is something that is going to be captured by the model that we have currently, because we have this unobserved heterogeneity where it affects the mean offer you get, and then ultimately also where you end up in the distribution. But at least what we can do is like, at most, residualize out. And I guess one thing, I mean, that's kind of the best I could do. I'm not quite sure how to deal with it. Like it was basically a model misspecification type issue if you think people are directing their search to particular salaries.
I guess the framing I would use is I'm not sure if people maybe would say that way, is that you need to impose some identifying assumptions on the data generating process. And
right.
I'm just asking whether you rule out such a world. And if you do, I'm fully on board. I just want to make sure.
It's basically, yeah, so the identifying assumption would be like conditional on all those observables that we have in the X's, plus the unobserved heterogeneity component.
There's no other systematic
There's no other
sorting across
that
different,
fully
like,
captures like where you're searching. Yeah.
Right. Yeah. I'm fully on board, just trying to spell it out. Yeah. Thank you. Great.
I'm gonna continue with the business cycle perspective.
Yeah.
The fact that you're finding the workers to be mostly pessimistic seems to be really consistent with the learning over the business cycle part, that post recovery, during the recovery process, that you update slowly to learn the as the offer improves over time. But I'm also thinking, if we were to redo the exercise, if we have the data today, it's possible that we're going to find workers to be more optimistic or mostly optimistic. I guess my point is that the fact that workers are pessimistic during that period of the data give me a lot of confidence about the learning story.
Yeah, I mean, so our data is from 2014 basically until the present. So it's true that maybe starting at 2014 is already at like the tail end or like maybe not fully out of a recovery period. So the best we can do to get rid of any cyclical stuff is use any variation over the full sample in the state of the aggregate labor market and just residualize it. And then what we're doing in terms of how we impose what people's true underlying, let's say, offers or mean offers are, is beyond what's being predicted by the average for everyone over the cycle. What does everyone who looks like you observationally, what do their offers look like? And then how do you deviate from them? So to the extent that like those offers haven't fully recovered yet because we have like a weird sample, that's true that it might still be picking up some of the cyclical stuff. But I think, we cover a long enough period of time that hopefully some of that is netted out. hopefully. Actually, that's one of the benefits of having dragged this paper out for so long is that now we have more data.
Yeah, yeah, yeah.
Shu?
Hi, Laura.
Hi.
Sorry, keep bugging you.
No, it's great.
So I'm kind of curious whether this happens in your model because this is my conjecture that this is something that might happen in your model, given that you have the assumption of the learning rule you have and myopia. And I think myopia might be doing something very strong in your model because they're not very forward-looking. And my
100%.
guess is, yeah, my guess is that there's some threshold mu star and some threshold gamma star that, I might have been like a superstar in the previous period, super optimistic. And then I draw something back that gets me to this mu star and gamma star thresholds, and I drop out. I actually leave because those are the thresholds that make it costly to participate in the labor market. And so you can just get this like sudden dropouts happening in your model just because I hit a bad threshold point because you have this linear learning rule. And as long as I draw something very bad, and since the history doesn't matter, right? I draw something very bad just at one time, I can be a sudden dropout.
Yeah, so let me make sure I understand your point. So let's say I simulated data for my model and looked at like one period to the next. There are going to be some people where at their initial beliefs they were searching, and then you look fast forward next period, all of a sudden they're not because they got some weird draw. Is that what you're asking?
Yeah, so let's say like I'm optimistic for a while, and then in the 100th period, I drew something bad, I suddenly drop out. And my guess is that in your model, they never come back because the only time you get information or signals is when you're looking for a job, right? When you've actually participated, because then that's when you can receive an offer and see the salary offer.
That's right.
Yeah, so I guess I don't have this is more of a comment, I guess, and not a very good question, a well-framed question, but it seems like myopia is a very strong assumption in addition to your learning rule. And I wonder whether there's a way to maybe relax the myopia assumption. It might be complicated because then all the things about search effort and thinking about if people know what their learning rules look like and they're forward-looking, maybe that complicates things. But
yeah, I mean, so I think your intuition is completely right about what it's doing in the model. We have solved, it's not easy to solve, but we have solved the version where they know their learning rule entirely, and they take that into account when they're making their search decisions and reservation wage decisions. It really didn't change much the actual policy rules, which is why we ended up ditching it. And I think it's just there's actually some results which say like you can just use this anticipated utility kind of thing as an approximation for the full sort of like learning model. And that actually numerically just seems to be the case. So we have that model solved and we have those policy rules and they just don't look that different. But you're right about the dynamics of what's going to happen. I mean, we haven't analyzed much the dynamics of like search or how long they stay in the labor market of actively searching. Tristan.
Hey, yeah, so this is kind of related to what Shu asked earlier. So you said you did a Bayesian version of this previously?
Not the model.
Okay.
Oh, actually, we did solve that. So we wanted to nest what Bayesian learning would be, but we didn't solve the whole Bayesian model because that would require also adding on, having not just the prior mean, but the prior variance at the individual level.
Right. Yeah. So yeah, I guess if you haven't done it, then I guess it's probably a bridge too far. But I mean I think it matters for potentially two reasons. The first, and these are kind of related to what you mentioned before, like if you take those integrals, it's not clear that they'll pass through. Like the value function's nonlinear, so that could be something. But then also, I think a kind of underappreciated thing is that if you do it fully generally, where people's have beliefs or model as distributions over these things, then there's also a covariance term potentially in there when you take the integrals. So
covariance between
between beliefs over the two
objects.
we're uncertain about, right? If you treat them as random variables, then you need to think about whether there's a covariance between them.
Right.
And that's I think interesting in its own right, that question, like, are people's beliefs correlated about these two relevant things? But I also wonder to what extent it would affect, what you get out of your model if you were to allow for that.
Yeah, actually, in the reduced form stuff, we actually looked whether the updating is correlated in terms of like, if you are, is your updating about the probability of receiving an offer correlated with like how far off you are in terms of your expectations about the mean and vice versa. It didn't seem to be the case. However, and this is not really consistent with that, our model actually would have like an interaction between these two things, even as is right now, because obviously like your behavior in the model depends on what your expected value is, like in terms of search behavior. You
Right.
care about the value of the offers, which is part of the return to search, and then the component of the actual return to search that you're uncertain about. So both things actually matter for your search behavior.
I see.
And also reservation wages. But actually in the data, they remarkably did not seem to be correlated.
Yeah, that's really interesting. Yeah. Thanks.
Great. So with that, we will conclude the webinar today. Thank you, Laura, for a really interesting talk, and thanks for everybody for attending, and to the
Thank you all for your
panelists
comments. I really appreciate it.
comments.
Great stuff. Great talk. Great to see everybody. Hey.